and welcome to our lesson in mathematics. We are still looking at compound interest, and in our previous lessons we have been calculating compound interest when the period is a year, 2 years, 3 years or more. That means when the period is in terms of years, bearing in mind that some of these rates are given per year or annually. And when we were doing that, just a reminder, our amount was calculated from the formula. Amount is equal to the principal into the brackets 1 plus the rate. Everything is raised to power n. And in this formula, we said that at the end of a given period, this is how we get the amount. This refers to the period, and this is the rate of interest, while this n denotes the number of periods that we have. So in those previous lessons, we also looked at how to adjust the rates based on the periods that we are given. We have already done that. So in this lesson, we want to look at how do we calculate the amount, that is how do we calculate compound interest when the period is less than a year. When we talk about the period being less than a year, we are talking about quarterly periods. Quarterly periods. We might also be talking about biannually. We can also talk about monthly periods. We can also talk about the weekly, when the period when the compound interest is calculated weekly, and in some extreme cases, the compound interest can also be calculated daily, though it is not common for the compound interest to be calculated daily. So these are some of the periods that we are going to look at. When we talk of the interest being calculated quarterly, we know that in a year we have 4 quarters, and biannually it means this is 4 times per year. 4 times per year. 4 times per year. While biannually means we are going to calculate twice per year, and monthly we are going to calculate 12 times in a year, while weekly we are going to calculate 52 times in a year, and in daily this will be approximately 365 times in a year. So having looked at this, let us look at how do we calculate the compound interest when the period is less than a year. An important point to note is that when the period is less than a year, then automatically this will lead to adjustments. On the period denoted by n, and also on the rates of compound interest denoted by r. We need to adjust these two before we feed the same into our compound interest formula for us to achieve the desired results that we are looking for. Let us start by looking at examples. We can start by looking at the first example. In our first example, we can look at Tony's investment of 4,000 is compounded at 4,000 dollars. Is compounded at the rate of 8.4% per year, per annum, over 5 years. Determine the amount he will have after 5 years. Determine the amount he will have after 5 years if the interest is paid monthly. If the interest is paid monthly. So this is the question that we are having. And remember, in our previous lessons also we said that for us to handle such a question, there are steps that we are supposed to follow, or some things that we need to do before we apply our compound interest formula. The first thing that we are supposed to do is for us to list the terms in the compound interest formula that we know and their values that we've been provided with in the question. In this question, the terms that we have been provided are like the principal P, which we are told is $4,000. Another term that we are provided with is the rate. The rate, we are told the rate is 8.4%. In one of the lessons where we dealt with the conversion of rates and periods, we say that if this rate is given per year and we are talking about a period less than a year, we need to divide this rate. We need to divide this rate by the number of periods that we have in a year. Because in this question, we are told that the compound interest is paid monthly. So in a single year, how many periods are we going to have? So that those periods, when divided by this, we will get the interest rate per single period. So this we will have to divide this by 12. 12 is the number of months in a year because our rates were given per year. So when we divide by 12, we will get our rates per month. Again, these rates, before we feed it into the compound interest formula, we also need to make sure that our rates are in decimal form. This is a percentage, and we have learned how to convert a percentage into a decimal number. We said that will be basically by dividing by 100. So when we divide by 12, we are converting to rates per month. Then we divide the same by 100 to get our rates in decimals. And when we do that, we will get 0.07. 0.007. This is our compound interest rates. Looking at the question again, we can discover that we have been told that this compound interest is going to be compounded over a period of 5 years. So another term that we are provided with is the number of periods. But in one year we have 12 periods. What about in 5 years? Because the compound interest is compounded every month. So this will have to be multiplied by 12 to get the total number of periods that over which this compound interest is going to be calculated. And this will give us 60 periods. That will give us 60 periods. We are through with the step number 1. We move on to the second bit of it. That after listing all the terms together with their values, we now need to write down the compound interest formula. The compound interest formula. Our compound interest formula is the amount is given by the product of the principal into the bracket 1 plus the rates raised to power n, where n denotes the number of periods. Having done that, the next step is for us to substitute in. Substitute in the values and evaluate or solve. We feed in the values that we have here so that our amount will be equal to our principal. Our principal is $4,000. Then we have 1 plus the rates. The rates, we are no longer going to use 8.4, but we use the adjusted rates because our period is less than a year. This will be 0.007. And also, you will also look at the number of periods that we are going to apply is no longer 5, but we are going to use 60 because these are the number of months in 5 years raised to power 60. Then this will give us 4,000 multiplied by, when you sum up this, you will get 1.007 raised to power 60. So having done that, you need a calculator to solve this sum here. When you look at 1.007 raised to power 60, it means it is this value multiplied by itself 60 times. And you cannot do that manually. If you try that, it will take a lot of time. So you take your calculator, you press 1.007, then you press the symbol for raising for the power 60. Having done that, you press the equal signs, then you multiply the answer or the results that you have with 4,000. And when you do that, this will give us, this will actually give us, it will give us $6,078.95. $6,078.95. Someone might ask you, what is the interest? What is the interest? Because the question was for us to calculate the amount, and after 5 years, this will be the amount. Are you able to calculate the interest? Yes. We said that for us to calculate the interest, is equal to the difference between the amount and the principal. The amount we have is $6,078.95, and our principal is $4,000. So when you subtract this, you will get the interest as $2,078.95. This is the amount of compound interest that will be accumulated over a period of 5 years. I hope you've understood the first example. I want us now to move on to look at a second example. And in this second example, we are going to use the same values, but different periods. The same values, but different periods. Try to compare and see what will be the difference when we adjust the periods. The second example is calculate the amount of compound interest paid on $8,000. Paid on $8,000 at the end of 3 years for each rate below. For each rate below. So we are going to apply several rates. And the first one, A, at the rate of 12% per year, compounded annually. Compounded annually. At the rate of 12% per year compounded annually. And just like our first example, you need to list down the various terms that we've been provided with together with their values. And the first one is the principal, which is 8,000. We have also been provided with the rate. This rate is 12% per year. So you discover that we are provided with this rate per year, and also the periods are in years. So we are not going to change that. This is just like in our previous lesson. We want to use this and several others so that we can compare. So these rates will remain, but we need to change the rates into a decimal number, and this will be divided by 100 for us to get 0.12. Then the number of periods that we have, we are told it is over 3 years. So our periods will be 3. Having written down the terms, we write down the compound interest formula. After writing down the compound interest formula, we substitute in the values. We substitute in the values. Having done that, we go ahead and solve now. This will be 1 plus 0.12. When we add that, we will get 1.12. Then we raise it to power 3. Then we multiply the results by 8,000. And when we do that, this will give us 11,239. 11,239.42 dollars. So this is when our rates are given annually and the periods are in years. Let us move on and look at the second bit of this question. The second one is we have the same rates, 12% per year, but this time round they are compounded monthly. Compounded monthly. Just like in what we have done here, we will have the same principle, $8,000. The rates will have to change. We will have new rates. We will adjust our rates to suit the periods that we have. This is 12% per year, but since it is compounded monthly, we need to know in 3 years how many months are those, or what will be the rates per single month. The rates are 12% per year. In a month, we will divide these rates by 12 months to get the rates per month. And then for us to convert the same to a decimal number, we will divide by 100. And this will give us new rates. The rate will be 0.01. 0.01. What else have we been provided with? We need to look at the periods. We have 3 years, and since the compound interest is going to be compounded monthly, we need to know how many months we will have in 3 years. This is times 12, giving us 36. Giving us 36 periods. That will give us 36 periods. Having written down these terms together with their values, we go ahead and write down our compound interest formula. And then we substitute in the values and solve. The principal is 8,000. This will be 1 plus the new rates, 0.01. And also the period will change to 36. When you look at these two expressions here, the rates were 0.12 because the number of periods that we had was in terms of years. This time round it has changed to 0.1. And also when you compare here, the periods are 3 and the periods are 36 because we have converted 3 years into months. That is 36 months. And this will give us 8,000 multiplied by 1.01 raised to power 36. And this will give us, when you do that, this is going to give us 11,446. 11,446.15 $0.15. So looking at the first and the second, there is something that you can notice. The amount here is just 11,239.42. The new amount we have when we change our periods to monthly calculations, you discover that it has increased the amount to 11,446.15. Let us look at the third question. We'll look at a third question so that we can compare all the three. The third one is for us to calculate the same rates per year, but this time round they are compounded daily. Compounded daily. It has been compounded daily. We need to list down the various terms. Our principal is still $8,000. The rates are still going to change. We have 12% per year. So we need to get the rates per day. In a year, how many days do we have? We have approximately 365 days. So every day, the rate per day, we need to divide the rates per year by 365 to get the rates per day. Then we divide again by 100 to convert the same to a decimal number, and this will be 0.00033. 0.00033. That will be our new rates. As we move on, you discover that the things that are changing are the rates. It is prudent that we adjust our rates before we feed the same information into our compound interest formula. Then we also need to look at the number of periods that we are going to have. Remember, in a single year, we have 365 days. And this compound interest is going to be compounded daily. So in 3 years, how many periods are we going to have? This will be 3 times 365, and this will give us 1095. This will give us 1095. This will be the number of periods. The number of periods that this compound interest is going to be compounded. Having written these terms and their values down, we write down our compound interest formula. It is standard procedure for us to do that. After writing it down, we feed in the values, or we substitute in the values. The principal is $8,000. This will be 1 plus the rates. The new rates are 0.00033. Then the number of periods that we have is 1095 periods. So if you solve this, I told you cannot do this manually. You need to use a calculator to solve the same. Just take 1 plus this and you'll get 1.00033. Then you raise the same to power 1095. Then you multiply by 8,000. This will give us, this is going to give us 14,481.44 dollars. $14,481.44. You discover that as the number of periods increases, the rates tend to reduce. If the rates were 12% per year, when we moved to monthly calculations, you discovered that the rates actually changed to 0.01. But as we move on to daily compounding, the rates are reducing again to a paltry 0.00033, a very small number. But cumulatively, those adjustments brings about a very big change in the amount that will be obtained at the end of the entire calculation. When you look at the amounts, when you are calculating the compound interest daily, the amount is quite high. When you compare this to this one that we have here when we were compounding monthly, And when you compare to the first one, which was 11,239. 11,239.42. When you compare this with this, and also in comparison to this, you discover that the more you increase the number of periods, the more the amount you will get. Let us look at the last question on this, the very last question, part D. The very last question. And the question is, what is the interest difference between annual and daily compounding in this case? What is the interest difference? What is the interest difference between annual and daily compounding in this case? In this case, we have been asked the difference between the interests, not the difference between the amounts or the principal. So we need to get the interest in each case. The interest when we were compounding daily, and also the interest when we were compounding annually. And remember, our interest is obtained from the difference between the amount at the end of the period and the principal. So we need to get the daily interest. The daily interest, we look at the amount that was obtained when we were compounding daily. The amount is 14,448.481, sorry, $0.44. That was the amount. Then we subtract the principal, which is $8,000, and this will give us an interest, a compound interest of $6,481.44. After compounding daily, this is the amount of interest we have. Then let us also get the interest when we were compounding annually. This will be the amount that we obtained when we were compounding annually, and the amount was 11,239.42 minus the principal, which is still 8,000, and this will give us an interest of 3239.42. That is $3,239.42. We have the two interests. Then the difference will be this daily interest minus the annual interest, and this will give us 6,481.44 minus 3,239.42, and ultimately we will have a difference of $32.02. This is the difference. What does this difference show us? It is showing us that if you are going to invest a given amount, it is good or it is prudent for you to take that option where the compound interest is calculated daily, because it will give you more returns, unlike when you have an option where the compound interest is calculated annually. The difference is here and you can see. So in terms of investment, this calculation can give you a hint on how to select the best investment choice available for you. Having looked at those two examples, let us look at a third, and it might be the last one. We look at a third example, and this one is a bit simple, but it requires you to be well conversant with the terms in the in the compound interest formula. Those terms, you need to have them at your fingertips so that you can distinguish which figure represents which term in the compound interest formula. So let us move on and look at a third example. We have a person by the name Sophie. Sophie does the following calculation. Sophie does the following calculations for a 5-year investment that she is considering. And this is 3,000 into bracket 1.04 raised to power 10. 3,000 into bracket 1.04 raised to power 10. So let us move on and look at the questions. We are just provided with this expression, just 3,000. In brackets we have 1.04, and above that we've been told that this figure has been raised to power 10. We don't know what these figures imply or what do they stand for. Let us look at the questions and try to solve them. The first one is, how much is she considering investing? How much is she considering investing? Do you have an idea of how much she is considering to invest? I might not have an idea, but you can have the idea. But for us to avoid the doubts and guesswork, we just move on and write down our compound interest formula. Because it is an expression that is somehow related to that, we move on and write down our compound interest formula, which is the amount is equal to the principal into bracket 1 plus the rates raised to power the periods. And try to compare the same with this. Let us compare the same with this. We can equate this to 3,000 into brackets 1.04 raised to power 10. So when you look at these two, when you look at the equation, you will discover that this automatically, these brackets should be equal to this bracket on the other side. And this power here, n, should be equal to that. And this power, from our knowledge that we have currently, this power should be equal to the number of periods. It refers to the number of periods. And obviously, this value here, 3,000, is equal to the principal. So with that knowledge, how much is she considering investing? She is considering to invest her investment, or the principal is $3,000. On to the next question. The second question is, how many times per year will the interest be compounded? How many times per year will the interest be compounded? We need to know the number of times that this interest is going to be compounded. So still from our compound interest formula, we can't be able to know the number of times that this interest is going to be compounded. We are told from the question that she is intending to invest this amount over a period of 5 years. Over a period of 5 years. So how many times per year? It means in 5 years, she is going to have 10 periods. And this means that in 5 years, we are going to have 10 compound interests. So what about 1 year? In 1 year, just 1 year. This will be equal to a year multiplied by 10 periods divided by 5 years. And this will give us number of times per year. The number of times per year will be equal to 2. This will be 2 times per year. 2 times per year is referred to as biannually. This is referred to as biannually. It is referred to as biannually. Twice per year. The next question is, what is the annual interest rate as a percentage? What is the annual interest rate as a percentage? As a percentage. The annual interest rate as a percentage. Still, we go back to the equation where we have the principal into the brackets 1 plus the rates raised to power n should be equal to 3,000 into 1.04 raised to power 10. We need to get the annual interest rate expressed as a percentage. We have said that this principal P is equivalent to that. And whatever we have here, this N, we have said principal is equal to 3,000. And we have said that the periods, the number of periods we have are 10. So this leaves us with 1 plus R being equal to 1.04. We have 1 plus R being equal to that. What is R? It requires us to split this number on the right hand side, where we'll have 1 plus R being equal to 1 plus 0.04. 4, such that when you take this you add on this, you will get this number here, and the same will be applied on the other side of the equation, so that our 1 here will be equivalent to this, and this r will be equal to that. So this means our rates will be equal to 0.04. What was the question? What are these rates, annual interest rates as a percentage? These rates, from our second calculation, we know that they were compounding by annually. So this means this is for just once in a year. If it is twice in a year, then we will multiply this by 2 to get the rates per year, and this will give us 0.08. This is a decimal number. We are told to calculate this interest, the rates, as a percentage, and we have already learned on how to convert a decimal number to a percentage. This is by simply multiplying the said number by 100%, and this will give us a rate of 8% per year. Our rate will be 8% per year. So having looked at that, let us move on and look at the next question, still on the same. This is part C. We look at part D. Part D, we are asked, at the end of the 5-year term, how much interest will she earn? At the end of 5-year term, how much interest will she earn? How much interest is she going to earn? This is a simple question. We have looked at the relationship between this, and this means it is just for us to apply the compound interest formula. And this we had already been given us. The principal is 3,000, and in the brackets we have 0.4, which is 1 plus the rates multiplied by 10 periods, because it is going to be compounded by annually. And the amount we have, the amount will be $4,440.73. This is the amount, but we are asked to calculate the interest. The interest is the difference between the amount and the principal, and the amount is $4,440.73, while our principal is $3,000, and this will give us $1,440.73. This is the compound interest that will be compounded over a period of 5 years. Having gone through the first example, the second example that held several sections, and now the last, which is the third example, I hope you have understood how to calculate the compound interest when the period is less than a year. We said at the beginning that it requires us to make some adjustments on 2 things. The first is on our period, and the second is on our rates. Once you make those very important adjustments, you feed the same information in the compound interest formula, and you will be able to calculate the amount. Or if you are required to calculate the interest, then you will find the difference between the amount and the principal that was invested. Let me now give you an assignment that will help you in revision. Our first question is for us to calculate the amount of compound interest. Calculate the amount of compound interest paid on $5,000 at the end of 4 years. At the end of 4 years for each rate below. For each rate below. And our first rate A is 12% per year, compounded by annually. Compounded by annually. That is twice a year. Secondly, 12% per year, compounded weekly. Compounded weekly. And we can also go ahead and look at what is the interest. What is the difference in interest? Between the weekly and annual compounding. And annual compounding. This is the question that I want us to use in our revision. I hope it will guide us. And when you want to calculate this compound interest, I'll require you to follow the several steps that I've given you and do the calculations keenly so that you achieve the required results that we want. In our next lesson, we will be looking at matters investment and loans, a very interesting lesson you can't afford to miss. Our second question on assignment is on person called Paula. She needs to decide whether to invest her $13,500 for 6 years. For 6 years at 4.2% per annual compound interest, compounded monthly, or 5.3% per year, compounded biannually. Compounded biannually. We are required to decide which investment would be the best for Paula. This is the second question. We need to decide the kind of investment that will be best for her. And for her to have the best investment is an investment where she will earn the highest interest. Or at the end of that investment period, she will have made, the amount will have increased the most. So this cannot just be determined from the face value or just by observing at these percentages and the period and the amount to be invested. No, we need to go down and calculate each case. We have the two cases where we have a 4.2% per year compounded monthly and a 5.3% per year compounded biannually. We go down and look at these two cases, bearing in mind that the period is 6 years. The one that will give us, the calculation that will give us the highest interest is the one that we are going to advise her to use. That is just a hint. This is another question that will actually help you in revision. I hope you will be able to solve the same. Thank you and welcome in my next lesson.